Hi and welcome to Maths class. Today we're learning about equations. So what you can see there is the word equations with an equal sign underneath it. That shows us how important the equal sign is to equations. So our first question then is, what are equations? So let's have a go at answering that, okay? Equations are number sentences like we've seen before, but they must have an equal sign and they must be true. So they are number sentences which are true, and they must have an equal sign in them. So they are two specific things that we know about equations. So for example, 3 plus 2 equals 6 minus 1 is an example of an equation. It's a number sentence which is true. So one of the things that you'll often be asked to do with an equation is to solve the equation. So what exactly does that mean? Here's an example. If I am given the equation x plus 2 equals 5 and I'm asked to solve it, then what it means is I need to find out the value of the missing variable. It means find the value of the missing variable, or let's call it the unknown variable. We'll call it pronumeral. Find the value of the unknown pronumeral. So we're looking for x, in other words. Now in this case I can do that easily. It's 3. 3 plus 2 is going to equal 5. So the value of the unknown pronumeral, which is x, is 3. I've solved it. Look for the word. It's important with maths to always read the instructions. When it says solve, it means they've given you an equation and it means you need to find the value of the missing pronumeral. So we're going to learn two techniques for solving equations in this lesson, but they're not proper algebraic methods. We're going to learn those in the next video. First, we're going to learn a thing called solving by inspection. And that's pretty similar to what I did before. X plus 2 equals 5. I just knew that the answer was 3. So if you can just know the answer, then that's called solving by inspection. So what I want you to do is just pause the video and have a look at these four and see if you can write down the solution to each one. Pause now. Okay, hopefully you've paused. So what I'm looking at here is 2. Remember that this is times. This is 2 times a number equals 10. So in this case, x is going to be 5 because 2 times 5 gives me 10. Here I've got x plus a number gives me 14. So I know that that number has to be 4. That's the solution to B. For C, I've got 11 minus a number equals 3. That's a bit trickier. 11 minus what is going to give me 3? So it's the same number that if I add 3 plus that number, I'm going to get 11. So the other way I can think about it is 11 minus 3, which is 8. Let's check it works. 11 minus 8 equals 3. Yes, it does. That means 8 is the correct value for x. And the last one, oh, I've written the wrong equation. That's a bit tricky, but we can still do it. Something divided by 4 gives me 24. I really wanted this to be 6, and I accidentally wrote down the answer I was thinking of. Can I fix it? Let's make that 6, and that's going to give me an answer of x equals 24, because 24 divided by 4 is going to be equal to 6. So if you're wondering what would be the answer to this one, what number divided by 4 is going to equal 24. So the answer that you want to that one is x equals 96, because 96 divided by 4 is going to give you 24. That's a bit of a tricky one though. Okay, but these ones are harder for a different reason, not because of the numbers, but because solving them by inspection is not so immediately obvious. So have a go at these. Pause your video and then I'll go through them. Have a go. Pause. Okay, hopefully now you've done yours. So let's have a look. x plus 4 equals 1. What number can I add 4 to it to get 1? Well, 1 is smaller than 4. So it's going to have to be a negative number, and that's what makes this one tricky. The answer is x is negative 3. Now, what's tricky here is I have to go 3 times x and then add 1 to get 10. So my thinking here is, well, if I have to add 1 to get 10, then this 3 times x bit must be 9. So my x is going to be 3. Let's double check it. 3 times 3 is 9, plus 1 gives me 10. Don't worry if you didn't get these ones. These are harder, and actually, part of the reason I'm showing you the harder ones is to convince you that we need another method than just inspection. Inspection can get you there for things that are easy, but when things get tricky, we need a proper method, and that's going to be in our next video. All right, the next one is 3 times, and then in brackets, x plus 1 is going to be 15. So I'm thinking to myself, 3 times what is 15? And the answer is 5. So this bracket has to be 5, which means that x is 4. And this last one is really tricky. 2x equals x plus 3. And this is the way I thought about this one. 2x is the same as saying double x. So what's the number which, if I double it, I get the same answer as if I add 3? And that's if x is 3, because 3 plus 3 is going to give me the same answer as 2 times 3. Don't worry if you didn't get it. So x is 3 for this one. All right, that's solving by inspection. Sometimes we have another method, which is called guess, check, and improve. Now, I'm only going to show you one of these. We're not going to use this a lot, but sometimes it's good to have a fallback method. So this equation looks pretty tricky. 5x plus 1 divided by 7 equals 3. I don't know. Let's just try something, all right? Let's try x is 3. Try x is 3. Because this method is called guess, check, and improve. So I've guessed 3. Now I have to check if it's right. So on the left-hand side, LHS stands for left hand side. I'm going to have 5 times x plus 1 divided by 7, but x is going to be 3. So that's 5 times 3 plus 1 divided by 7. The 5 times 3 I have to do first. That gives me 15 plus 1 divided by 7. That's going to give me 16 over 7. That's not even a whole number. But I know that it equals 2 and 2/7. But I don't want 2 and something. I need it to be 3. So the improve bit is where I look at my answer and I think I want it to be a bit bigger. So I'm going to try the next bigger number. Now I'm going to try x equals 4. So the left-hand side now is going to be 5 times 4 plus 1 over 7, which is 5 times, you can't see that. 5 times 4 is 20 plus 1 over 7. This is looking promising, which is 21 over 7, which equals 3, which equals the right-hand side that I wanted. Let's double check that. See? So when x is 4, I get 5 times 4, that's 20, plus 1 is 21, divided by 7 is 3. So yes, x equals 4 is the solution. Now, what I did there was a little bit of checking my answers, and I haven't really taught you properly how to do that. So that's the last thing I'm going to quickly do now, is just show you how we can check a solution. All right, so I'm going to use substitution to check that the solutions are correct. Sometimes you find a solution and you're not sure if it's right. Or maybe someone else tells you the answer and you're not sure if you trust them. So you want to have a way of checking that's not the same as just doing your method again. Because if you just do what you did again, If you made a mistake the first time, you'll probably repeat the mistake. So we can use substitution, which we've already learnt how to do, to check. So my first example is to check, is x equals 3 the solution to 4x equals 12? Now notice I'm not going to look at the equation and go 4x equals 12. Okay, I think the answer is 3. And I do think it's correct, by the way. But that's not what I'm going to do. I'm going to use substitution just like I did just now. I'm going to jot down left-hand side equals 4x. And when x is 3, that means 4 times 3, which equals 12. And that equals the right-hand side. So yes, it is a solution. Great. Let's do another one. Is x equals 9 the solution to 22 minus x equals 14? How about you pause, do it yourself, and then hit play and watch me do it. Off you go. Okay, I hope you're back, and I hope you got the same answer that I'm going to get. So I'm going to jot down left-hand side equals, this is the left-hand side of the equation, 22 minus x. So now this time I'm going to substitute x equals 9, because that's what I'm checking. 22 minus 9, which equals 13. 22 minus 9 is 13. It's not 14. Therefore, no. X equals 9 is not the solution. Now notice the question doesn't ask me to find the solution. It just asks me to check whether this is the solution. Here's another one. Is x equals 5 the solution to 30 over x equals 6? Same thing. Pause the video, do it yourself, and then hit play. Pause. Okay, let's try it. Left-hand side equals 30 over x, and I'm going to substitute in x equals 5, so I get 30 over 5, which is 6, which is the right-hand side. Therefore, yes. And I've got one more, only slightly more complicated question. D, is x equals 2 the solution to this equation? Okay, pause the video, try it yourself. Okay, let's do it. Left-hand side equals, I'm going to write first the original left-hand side, 2x plus 5. Now I'm going to substitute in x equals 2. So 2 times, instead of x, I write 2 plus 5. And then I have to remember my order of operations, brackets first. So I have to do this addition inside the brackets first. So 2 times 7, which is 14. So no, it doesn't equal the right-hand side. No, not a solution. Okay, that's the end of our introduction to equations.